A complicated task needs to be done with multiple programs collaboratively. Take the study of the performance of a certain device as an example. You feed the device parameters into a simulation program, the output of which is fed into some analysis program. The output of both needs to be fed into a visualization program for plotting. All programs need certain configurations and libraries to run in a consistent way. It is hard to copy such a complicated combination faithfully from one computer to another without making any mistake. Unless you share the whole thing, including the operating system, where they are running as a single package. This is called a container. It must be as small as it can possibly achieve for easy sharing and a massive deployment in various operating systems, which may or may not be the same as the containerized operating system. Docker Desktop is a popular program that does just that. Let's take it as an example to demonstrate the basic usage of a container. It runs on multiple operating systems. Let's download the one for Windows as an example. Click the downloaded installer to start the installation. Some of the Windows users may see an option talking about using WSL to replace Hyper-V. Check the box as recommended. WSL2 is roughly a lightweight Hyper-V, and Hyper-V is a program to run virtual machines. Click OK to finish the configuration. The installation may take a few minutes. After a successful installation, Docker Desktop should appear in your Start menu. It takes a few seconds for the Docker Desktop daemon to start. Some of the Windows users may see an error message complaining the incomplete installation of WSL2. Let's just follow the instruction and click on this link to install the WSL2 Linux kernel update. The link will take us to a Microsoft web page to download the kernel update package. Click here to start downloading. You may receive a warning message when you try to run the downloaded MSR file or the Microsoft Windows installer. Don't worry about it. Click OK to continue. And the next and finish to finish the installation. Now we can go back to the Docker Desktop and click Restart. When the Docker Desktop is up and running again, it offers you a chance to go through a 2-minute tutorial. Click Start to do it. The tutorial consists of 4 steps. The first is to download Docker Getting Started from github.com by running a few lines of commands in a terminal, which can be the Windows PowerShell showing on the right of the Docker Desktop or in a separate terminal app in a Mac. The commands here are too complicated for a newcomer to type it correctly to the terminal. Fortunately, you just need to click the blue box to copy and paste all of them to the terminal on the right. Click Next when you see the command prompt shows up in the last line again. The second step is to get into the Getting Started folder that we just downloaded and use the instruction inside to build a container image called Docker 101 tutorial. Click the box to run the command in the terminal. It may take a bit longer this time. You know the execution is finished when your command prompt shows up again at the bottom of the terminal. Click Next Step to move forward. The third step is to run a container called Docker tutorial based on the container image Docker 101 tutorial we just built. The output of the terminal may mess up. Your command prompt may show up in a strange place, but this doesn't matter. Click Next to continue. The last step is to share the image we just built, which is optional. If you don't want to do that, simply click Done to finish the tutorial. The Docker desktop will tell you that your first container, Docker tutorial, is up and running. It's running a web server through port 80. Click on this icon to view the served web page in the browser. Your browser will show you a tutorial web page hosted in a container running locally. Depends on the size of your browser window. The list of pages may be hidden in the icon or shows on the left of the page. Read them at your own pace. For now, let's just go back to the Docker desktop window. In the container list, we see two containers. The first one was used to download the tutorial. It is not running. The second one is still running. It is serving the web pages we just saw. If we navigate to the list of images, we see two there as well. Each of them was used to create the corresponding containers we saw in the list of containers previously. When you push the play button, a container will be created based on this image. One image can be used to create multiple identical containers. Let's click on the play button to run a new container based on the same image again. In the optional settings, specify a host port different from the one we used before, which is 80. Let's try 81 this time. Your Docker desktop will assign a random name to the container and show some output messages from the container if there's any. In the Inspect tab, we can see that the container is running a web server at the port specified by us. Click the icon to copy the IP address and paste it to your browser's address bar and press enter. You will be able to see the same tutorial served inside another container. Go back to the list of containers. You can see indeed two containers created from the same image with different names are running in parallel, serving at different ports. You can click the icon here to stop and start the container as you wish. Running a web server is probably not what you want to do with a container. Where can you find images that do things you want to do? Click the search box and the Images tab to search for it on Docker Hub, a website that hosts thousands of images. Say you want to download the official Ubuntu image from the hub, just click the pull button to download it from Docker Hub to your local disk, and the run button to create and run the container from it. This time, however, the log tab shows nothing, and the status of the container is exited instead of running. What went wrong? Nothing went wrong. This is the expected behavior. To understand this, let's go to the Inspect tab, where we can see that no program, such as a web server, is assigned to run by default. The container has nothing to do, so it just quitted immediately. We need to find a way to get into the containerized operating system and run programs in it interactively. This cannot be done inside a Docker desktop. You need to run some command in the command line interface. In a Mac, you can just use the Terminal app. On Windows, you can start a PowerShell through the Startup menu. Type docker space -- help to learn more about the usage of the Docker command. The command we need is docker space run space -id space followed by the image name. Docker is the main command. Run is the subcommand for Docker. -id is called an option. It simply means interactive terminal. You need an interactive terminal to communicate with the container that runs Ubuntu in it. If this runs successfully, your command prompt will change to something like this, telling you that you are already inside your container. You can use some command to verify that you are indeed running the operating system that you intend to use. Type exit to quit from the container, and you will be back to your own laptop. To summarize, container is a great way to share a set of programs for a specific task all together. Docker Hub is a website hosting various containers, and Docker Desktop is a program to communicate with a Docker Hub. It can also be used to build, use, and manage local images on your desktop. Containers designed to run some background services, such as a web server, can be started and stopped directly in Docker Desktop. If you want to interact with the operating system inside the container, you need to use a terminal and run the container image with the IT option.